Okay, so welcome to this short lesson on soils. So we're looking at different types, how to quantify it, and how it might be of forensic value. And here's a nice example of both the typical brown earth soil on the left and a more tropical, deeply weathered soil on the right. Obviously, visually different, both in colour, texture, grains, thickness, and etc. So hopefully give you a little basic example of what soils are in soils, the different types, why they occur, and more importantly probably cover some case studies, think about sampling strategies and why that might be useful in forensic evidence purposes. So soil's really important, obviously, for our food in it. And simplistically, bedrock, actually, as in the hard rock beneath your feet, gradually gets broken down after about 1,000 years into soils. Well, there's not much in Iceland, interestingly. And so the actually soil formations called pedogenesis, and there's actually the World Reference Database on soil classifications. But for our purposes, there's physically obvious differences in colour and texture, performance, and obviously overlying vegetation as well. And you can see it here in a global map of different soils. The details aren't important, but you can see the colours on the map, and you can see there's sort of a very much a horizontal latitude variation of these soils. Not everywhere, obviously, but you can see these different types come from different latitudes in the globe. And usually, as I mentioned, mostly soil gets broken down from bedrock, and that's called a residual soil, or it could get transported by things like rivers, wind, coastal gravity, all that sort of stuff, and glacial. And that's quite important actually, because most of the UK is covered by glacial boulder clays, the stuff deposited in the last ice age, certainly north of the Watford Gap. So it tends to be unsorted or poorly sorted clay-rich soils, which has follow-on effects for other search methods such as radar, for example, if you read that or listen to that lecture. Residual soils, that gets broken down by your standard A-level geography stuff, store action, biogenic processes, etc. You can see on the top right here, talking about the bedrock, the base geology, and then your different soil horizons, which get simplistically split into O horizon, the top organic rich horizon, the A horizon, which is a mixture of organic and minerals, B horizon, which is mostly minerals, and then down into C. So as I mentioned, the O horizon, that's the top part, mostly organic material. So obviously you're going to have mineral grains in there, obviously air gaps, water, and organic material as well. And again, there'll be big variations on that depending upon where you are. Even in the UK, there's big variations on both in the latitude and also west to east, because we get more rain from the west, so we get wetter, peaty soils in the west. Loads of different types in there. Urban soils are a bit more tricky. And again, there's a university in Scotland looking at trying to characterise different soil distributions sort of analytically, as you will, to try and match stuff up. You can sort of it's more qualitative analysis of soil. So this is a US system. I've got these little soilments or colour charts. And you look at the colours of your soil on a soil sample, and then try and link it to like a number. And basically, each card number has a particular number, and then you have to work your way across and down on each of those to give you like a list. So you normally have like the number is like 7.5 YR, that's the card number. 5 will be the X axis, and 2 will be the Y, and then you come up with a sort of a value. It's a little bit qualitative. It is affected by things like if it's wetter, it tends to be darker colours, and if it's darker light, it also tends to be different as well. So you tend to do it outdoors in the field when you collect it. So that's quite a useful method rather than indoors in a lab. So here's some examples. So Kentish soil, quite brown, you can see there, the spade for scale, and then you've got like a more of a podsol type in the New Forest Way leached material. They're quite different visually, hopefully, as you can see, and also mineralogically. So generally sort of develops in these sort of residual soils, and in this plot you can see distribution of different soil types. Again, it's not important the details in here, but for example, the west is very much pinker. Cornwall, Wales, the Lake District, that's often related to the bedrock types. And then you've got some greeny in the middle, and then you've got some more bluey glaze soils on the east. So again, if you do find some soil, and you might be able to at least work out where it isn't likely to come from rather than where it is. Okay, so soil texture refers to the sand, silt and clay proportion of any soils. You can see there on this ternary diagram, sand in the bottom left, clay top and silt bottom right, and obviously most soils will contain a variety of these. You can see there's different types in here. So weirdly, loamy sand is more proportional than sandy loam, if you notice that. I'm not quite sure why that is. There you see a lot of it sort of silty clay loams as well. It's quite difficult to quantify this. You sort of dry it and put it through a grain size granulometer, I think is that the word. You could do that, or you could actually do some more sort of qualitative handheld versions on here, like this Geography 101 version. So rolling it into a ball and a marble and flattening it into a sausage and breaking it. Of course, this relates to or dependent on how wet the soil sample is, but you can get a rough idea of what the soil type might be using those sort of things. So you can try that on a practical. And really, soil structure-wise, is a normal one is normally has different layers in it. It's normally crumb or granular. Most soils are like that, as you can see there in the sort of subdivisions. And that's you can sort of see whether it's well structured or not. So if that's useful. So obviously you've got to try and collect your data sequentially. So if your soil is layered, then you want to take samples, and obviously you should sample each layer, put them in sort of sealed containers. Sometimes for wet samples you should air dry them before you seal them. Stop worrying about if it dries out, starts to grow salt crystals or microbes growing it, things like that. So you need to keep it cool. Obviously if it's more coarse material, you might need to collect a bigger sample, etc., and then try and before you get to the lab. And generally for soil surveys, most of that's done remotely these days. It's like an aerial shot of soil. You see just about see those little lines delineating different soil types, and you basically, once you've done that, you go in the field and check which ones are which, because a lot of it's related to both the landscape, topography and vegetation as well. So a lot of people work on that, and hyperspectral data for these days as well. So there's a few case studies looking at this. Pi et al. 2005 is a classic case looking at sample repeatability, trying to see how variable a field or a soil site might be by collecting a variety of samples from the same location or locations, and then seeing what the variability is to say, well, how many should you need to sample to make it statistically significant. So that's quite useful. So he went back to a couple of old crime scene sites in Berkshire where he was, I guess, and did some basic and more advanced analysis of the soils he collected. So here they are themselves. I think Simon's Wood on the left, that's a robbery, and then Arborfield Bridge on the right was a murder. I think someone was found on fire dead beside the road or in a lay-by. So each of those sites he had a look at. You can see that this is a typical example of a map showing the area. You've got like the solid, that's the bedrock style, so you've got different bedrock types there, and then the drift, that's the soil type on the left on that key, showing you what the different types of soil might be. So that's quite useful information. Obviously got a plot work showing where each one is. And at both of these sites then he collected 9 samples with presumably the centre bit for each one, and then other ones around there in a sort of a subset, for example. So it's more of a grid at that first one near a path, and the second one was near the body, where the body was found. And then trying to collect about the same amount of material at each one, storing it sensibly, homogenising it, removing the coarse organic matter fraction, so that's leaves and things, sieving and air drying the samples, and then analysing it, and really trying to see what the differences were. So the key results for his was there's relatively low variability within a metre sampling scales. Some of the sort of major and trace element stuff you might be familiar with is quite useful. Colour wasn't that useful. Particle mode size was useful, and the key finding from that is really saying you need 3 samples to get sort of 70% of variability, and you need 5 to capture 90% of variability. So if you are collecting samples in the field, then 3 at any one point is probably the minimum, or at least from a small site. And then some other idea on which is useful and which isn't. Another case study, STAM in 2003. This was in California in the US. So a woman and her 2 kids were kidnapped by her ex-partner, I think. She was assaulted. They hid in this lake, or saline lake, for over a day, so they didn't have any DNA evidence to link him to the crime, but they did obviously arrest the suspect. They took the shoes and the clothes off him, and then also went to the crime scene itself, took samples, and then had a look at some of the minerals that were in the soil collected from his shoes primarily, and they're a pretty good match. You can see here on the right hand side these sort of graphs of mineral types. So details aren't important, but you see they're relatively similar. And there's even found a freshwater snail, which is quite unusual at both locations, both in the shoes and in the crime scene. They use this evidence to convict him of the assault. This one's an interesting one. So this is where in China there was basically some soil dumped in the road for whatever reason, which caused a crash, and 2 died and 1 was seriously injured. So that was trying to obviously work out where this actually happened. So you've got some little plots here of where it was in China, and then then the map of the area, and then where the mound was found. So actually looking at the soil type itself, looking at things like the physical characteristics I've already told you, elements in there, and actually magnetic susceptibility, which I've talked about in the geophysics lecture, to work out where the soil might have come from. And they actually probably got a good link to where it came from, but they couldn't actually say who did it or not. So again, you can read more about that if you wish. Ian Huntley's probably one of the infamous cases using sort of micro soil evidence. So this is the janitor at the school where these 2 schoolgirls went missing, which he's obviously got convicted of the murder for. And they actually found so two micropaleontologists were working up by the police and say, well, where's this sample coming from? Because they've actually seized this sample from the bottom, the car arch of Ian's car. He'd actually cleaned the car quite well, but hadn't cleaned underneath it. So they found these little microfossils, these chalk fossils, and tried to actually try and work out where that was. And actually, the little specific fossils are quite specific to a fairly narrow age in time and location when they started looking at the British Geological Survey borehole information. And certainly it showed it was in a relatively small area found in the UK, only within that 15 by 2 kilometre area. Or further away from that, you had different microfossils and in fact different mineralogy proportions in there as well. So the farmer actually dug this up from the fields and put it on the road to make it easy to go across, I guess. So they did have slightly different ages, but certainly it was a unique microfossil way. And when this was presented in court in the prosecution, the defence didn't challenge it, and in fact he changed his story to say why he'd gone down that road. And in fact, botanical evidence as well recovered from that scene showed he'd actually gone twice based on the spores and pollen for reasons that are unknown. Okay, so this is one from Alistair's book, looking at someone who was like a post cold case almost, unsolved murder of a sort of a prominent community figure found dead beside his car. You can see the burnt out car there on that top list, and they were trying to look at the scene and try and get some more information about what had happened to him. Had he died where the car was, or where he'd actually been abducted from his place of work? So they actually looked at revisiting some of the evidence that was there. So you can see the bottom example. There's some shoes, some clothes, some mud on it, and different materials. So that's actually sampled, as well as going back to the actual sites as well to see what they could find out. And actually looking at some ICP, I think, in here, looking at some analysis, and again, details of specific minerals aren't important. You'll notice some peaks look similar, smectite being the first big peak on the left-hand side. Then you've got a variety of other types as well. Quartz are some of these big middle peaks, and then some of the other ones are showing some differences and similarities. And that's sort of trying to show that the genes and the body deposition site was a little bit different to the actual community where he actually worked. So again, that's trying to look at where that happened. So read about that in more detail. He also worked on a bank robbery as well. So this is in Northern Ireland. A bank employee and his wife were kidnapped, forced open the bank for thieves. So the police wanted to know where they were being held before they got released. So the kidnappers were quite clever. Actually, they actually washed the kidnapped husband and wife's shoes, but they hadn't washed their socks. So the two of them worked out roughly where they'd been kept and released, but not sure where. So they actually washed the socks to try and get some samples, and they visited the victim's house. Here's a map showing you where the house is and where the samples that they took from were. Each of these little black dots, you can see them numbered there. Then they went to where they thought the hostage house was, and took some samples around that. So you can see that it's not in a random pattern. They've sort of clustered them around the house, as well as a transect and a few control samples. And then finally, where they were actually released, I think they'd been transported in a car, which then they'd burnt out. Again, trying to locate where they were. So it took some more samples in that area. And it's quite a clever way of doing that. Sort of, they actually centrifuge the socks to get the material out. You can see visually where they were here. So you've got the sort of hostage houses on the sort of bottom central part, and then the drives, and then the socks on the top. So I found quite a good match with the house. But more interestingly, is the criminals are trying to keep up to date with these sort of scientific advances. And certainly for accumulated soil, I mentioned that in the very first talk. We talked a bit about Sherlock Holmes sort of accumulated soil, trying to work out where someone had been walking through and which types, if the soil's different in different areas. And that's certainly something of interest. So this Bull et al. Reference, a bit old now, but certainly was looking at going through a murder case, and I took some soil samples off a suspect's shoe, and then trying to work out where they'd actually travelled from. So looking at things like fibres and hair, standard forensic stuff, as well as more sort of mineralogy as well, and how they might have walked through such a site. And it looks like they had 3 different soil types based on the mineralogy that they'd been given there. They'd also looked at pollen as well to see where they might have been, and it looks like the person who they'd got the samples off had actually gone across a stream and gone across a field and gone into the stream. They're actually picking up some water lily pollen, which doesn't tend to travel far apparently. So that's giving you a lot more information about trying to retrace their footprints, excuse the pun, for that part. This would be some more recent research as well, looking at this sort of thing, looking at soil samples and clothing materials and where that might have come from. So Proctor's a good reference for that if you want to read about sort of trying to make some scenarios and then working out what evidence they could actually collect from those. And certainly in that, they're trying to create different types of environments and seeing what material might come from, and then trying to divide things like clothing styles. So we've got cotton, denim, fleece, nylon, and leather, and working out the sort of material properties or how much we can get transferred from the environment to those particular clothing styles. I was trying to help the forensic investigators to work out what to look for next. Certainly fleece looks quite good in the park, for example. Cotton looks generally good most places other than the park, dry park, I guess. So again, it's trying to work out what sort of types to try and concentrate on. And certainly when you're thinking about soil, you need to be thinking about, well, is there a match? Is it easy? Is it difficult? And certainly in the past, soil scientists have tried all sorts of sort of flashy mathematical methods of trying to correlate material A to material B. And that's obviously for your non-experts, it's going to be a little bit confusing to jurors, and certainly multivariate analysis on PCA stuff I'm not sure myself. So certainly there's been recent cases where it's not really, is it significant or not? So one way to get around that perhaps is making a sort of database. And in the UK, for example, we've got quite varied soil types and bedrock styles, so that might be one method you could use and to try and relate to where it is, or at least where it isn't. A bit more problematic in urban areas because there's much more variety of materials, both natural and artificial, which I'll talk about in a separate lecture if you haven't listened to that already. So if you were going to say work for the prosecution, what would you do first? You'd attend a briefing session, you'd read the information about the case, you'd then carry out your examination of the material that you've got from the suspect, for example, or soil samples. You might go to the scene yourself, collect more control samples, analyse that data, start putting some results and data together, put some graphs together perhaps, maybe relate to a reference database, maybe collect more samples if you needed to, analyse those, put your results together, give an idea of what, based on the data you think has happened, write your report with a statement, and then give your attendance in court. If you're working for the defence, you get the prosecution reports. They've gone through that stage already. You will then maybe ask more questions from the defendant, perhaps, or their solicitor. You'd maybe go to the prosecution's lab to look at the stuff, see what they've done, subsample maybe and analyse stuff yourself. Maybe you'll go to the crime scene yourself, collect other samples, try and cast doubt that the other report was good, I guess. Do some analysis, compare your data, write what you think has happened, write your report, and then give your court evidence if required. And certainly there's not a lot of soil experts out there, and they can often switch roles depending upon who's getting employed where. And as I say, they've gone away from those sort of statistical methods, and they're trying to give a bit more of a schematic, well, sort of a weight of evidence scheme. So here's some examples from one of Pye's later papers, talking about limited to strong evidence to support stuff, none to conclusive suggestions that they're similar, based on a ranking, maybe 0 to 10, and then our types of evidence. So things that are different to things that are very, very similar. And certainly it's easy to say things are different and they're similar, much more hard to get a match unless there's some unusual, for example, a rare mineral in both samples that's not found commonly. So those sort of, that's what you're looking for, I guess, to try and get a match. Certainly it's a lot easier to say things are different than trying to say it's conclusively from the same spot. That's you're on very difficult ground if you're saying that. All right, so you've had a little bit of an overview on soil types, looking a bit about on material types, and sort of I've just briefly talked a bit about unusual materials, quite important for these sort of cases. And certainly I've shown you a few examples of that. And certainly urban areas is where they're still having problematic issues. And again, that's where a lot of crime happens. So that's something that needs a lot more development yet. So again, there's some references there for you to read about the cases I briefly talked about in this presentation. Thanks for listening.